Okay, so I'm going to continue on the theme of southern Australian seagrasses, talking about recruitment facilitation work that we've been doing for probably about 15 years now in South Australia on Amphibolis, Antarctica. So off the Adelaide metropolitan coast, so here in southern Australia, we've lost more than 6,000 hectares of seagrasses since 1949. It's shown a fairly unusual pattern of loss from shallow water to deep and has been attributed primarily to eutrophication and turbidity. The main taxa lost have been Posidonia and Amphibolis, and there's been substantial investment in reducing sewage inputs and stormwater inputs to the system that have now substantially improved the water quality, indicating that there's potential for rehabilitating these areas. So this is just a map of some of the areas of loss. This is just since 1995. So the areas of orange and red have been lost. Green is still seagrass in 2007. But a lot of this yellow areas, which is now sand, was lost prior to 1995. This is just a video adjacent to our main site showing that we do still have extensive stands of natural, fairly healthy Amphibolis, but we've got a very, very clear demarcation between the edge of the bed and where it's been lost. And here you can see extremely high levels of bioturbation. So this bioturbation, as well as winter storms, is what's preventing natural recruitment and re-establishment of these seagrasses. Basically, now we can go out in summer in particular and see lots of Posidonia seedlings established there, but they quickly get buried. Anything that does survive through to the end of summer gets ripped out in the next winter storm. So we started off trialling a number of transplantation techniques and looking at seedlings and different other ways that have been used elsewhere around the world for rehabilitation. But Adelaide has got fairly high levels of water movement and wave action for seagrass meadows. And as a consequence, we found that all these things quickly got lost and didn't establish. But incidentally, a couple of the people working on the project noticed that Hessian that was being used to try and stabilise some of the transplants was catching all these Amphibolis seedlings. So here's a picture of an Amphibolis seedling. Gary mentioned briefly they're viviparous. They release these seedlings are about yay big, maybe 5 centimetres long, and they've got this little grappling hook essentially on the end of them. So naturally what happens is this gets entangled into exposed root mat of Posidonia and that sort of thing. And we found that Hessian sandbags act as a good mimic for that exposed root mat. And they can get seedlings attaching onto them into the hundreds, even thousands per square metre. And some years later you'll see a sandbag looking like that, just a dense patch of Amphibolis. So we've tried doing a number of different experiments with these sandbags, trying to work out the best technique. This is just an example of our study site, our layout. Sandbags put out in rows, about a density of 1 per square metre. You can see here, I think this is about a year later after we put them out, we've had good recruitment of Amphibolis seedlings onto them. So one of the advantages of this technique is that we can basically, in operational situation, throw the bag over the side of the boat and forget about it. And the seedlings naturally attach to it. We don't have to go out and plant them or do anything like that, which means we don't need divers or anything, so it becomes a lot cheaper. And so I'll show some data from some of our earlier trials in 2008. Initially we got very high recruitment rates per bag, up an average of over 200 in some cases. So this was the bags deployed in May, these recruits are released around about June or July. So a May deployment is fairly good. If we put the bags out too early, they start to deteriorate and get covered by sand and don't attract as many recruits to them. So early on we were quite pleased about this, looking very promising. Second year, those same bags, some of them were attracting a second pulse of recruits and dying off over time, but still looked like reasonably high numbers in some. So this red dashed line is natural stem densities in the adjacent meadow. But then things started looking pretty crook. And over a period of years, often these bags only had a few stems on them, and they were looking pretty much like they were going to fail. Luckily, I was persistent and kept going back year after year and looking at them. And 5, 6, 7 years later, they started to increase in stem densities again. So these seedlings just took, 5 or 6 years or more to really get themselves established, get the resources together that they could then start sending out new shoots and starting to increase stem densities. And so it's quite a long-term process to start getting these established. And if we look at growth rates, individual plants after about 4 or 5 years were getting to about where the stem lengths in the natural meadows were, and then for a few years they actually increased further before declining towards the end of the data that I'm presenting here. And so this is just a video showing one of our re-established patches. Here, after about 7 or 8 years, the different bags have started to coalesce. You get seagrass filling out between them. So you can see we've got fairly good stem densities here, and just at the end you can see we've also got now Posidonia recruits starting to come in naturally. So the Amphibolis has now modified the water and sand movement enough that other species can come in. As well as looking at the actual seagrasses, we've been doing a bit of work with one of my PhD students, Chloe McSkimming, looking at faunal abundance, and she's found it in at the restoration areas. So plots put out in 2007 had good high levels of fauna. 5 years later, actually higher levels than in the natural meadow. In 2009, so plots that were put out in 2009 and were 3 years old were similar to the natural meadow, and even the 1-year-old plots from 2011 were fairly similar. So get rapid colonisation of fauna. This is the epifauna, but infauna was also similar. So these plots are actually starting to look and act like natural plots of established Amphibolis seagrass. So that was at very small spatial scales. We were putting out generally a few tens of bags on any one deployment. What happened if we move up into a 1 hectare plot? So we tried a plot, or actually we've done 3 plots now of 1,000 bags per hectare. And that's our red bar here. After 6 months, we found that very disappointing. We had about 5 or 6 stems per bag. All of this is data from some of our small-scale trials showing the number of stems per bag after 6 months. The low densities are bags that were put out shortly after the recruitment season, so they had to wait about 10 months before a pulse of recruits came through and it started deteriorating. The high abundance bags were put out around May, which is when the the 1,000 bags per hectare trial was put out. So after 6 months, it didn't look like we were doing too well. But after 20 months, if we look at the same situation, they're now starting to look much more like the bags that have been put out during the peak of recruitment in the small-scale plot. So very poor recruitment, but good persistence in this larger scale plot. Unfortunately, when we went back out there last summer, we found that all our marker stakes had been ripped out, and we weren't able to get sort of any data on how many stems per bag that we still had. Now, forget what I was putting this in for, so I'll skip that. Now, most of that work has all been done on Amphibolis, so we've got now a very successful method of establishing Amphibolis at small scales, but at larger scales we still need to do a bit of work to get it working. We've also trialled it with Posidonia, the other major species group that has been lost from the area. Here, as Gary showed a seedling in his talk, they don't have the structures that allow them to naturally attach to these bags, so they have to be planted in to them. So we initially did that manually with divers after the bags were put out. And here's just another example of some of our bags set up. These have got different substrates in them, different mixes of sand and clay. And here we can see that over a number of years we get very good leaf counts in particularly the 50-50 sand-clay mix. So again, very successful survival over time, but a lot more time consuming. What we have done more recently is tried planting seedlings into the bags on the boat and gluing them in and throwing the bags over the side of the boat, and that actually works just as well as planting them with divers. So it's still more time consuming than the Amphibolis, and is only ever going to be applicable on a fairly small spatial scale. But it is something that we can now do fairly easily, and we don't even have to go out diving or anything to get these seeds. They all wash up onto the beach just outside our lab, and we can go along and collect them off the beach and use them successfully. So this is just an example of a bag after a couple of years, showing a few well-established plants and a broader scale plot shot of our plot at the same time. So still fairly broadly spread out, but they look like they're going to follow the same pattern as the Amphibolis and become established and hopefully eventually coalesce. And I'll let it there, thank you.
Well, thank you, Jason. Are there any questions?
Yeah, Jason, thanks for that talk. It's very interesting, and I know about the work, of course. We have talked about it before. I was just interested to know roughly about costs per hectare of this Hessian bag method for Amphibolis, and now that you've shown the Posidonia, that will be much higher, but the cost per hectare, having lost 6,000 hectares, how much would that cost to replenish 6,000 hectares is another kind of question.
So I've done the calculations for us to do it as a research organisation at about 10,000 Australian dollars per hectare. So that's actually 1-to-1 exchange rate with the Singapore dollar at the moment. So if you actually scaled it up and got the engineers involved to scale it up properly, I am told that you'd expect the costs to be about 30% of that. But I haven't actually had it properly costed, but the standard rule of thumb is that when you scale up, apparently you're looking at 30%, so $3,000 a hectare for Amphibolis. I haven't tried doing costings on Posidonia because you wouldn't even be looking at it trying to do a hectare. You might do 100 square metres or so. Or the other thing you might do is throw some Posidonia bags in amongst your Amphibolis at a much lower density. But whether that's even needed, as my video showed, you get the Posidonia recruiting in naturally eventually anyway.
Thank you, Jason. That was a great talk. I just wanted to ask if, I'm intrigued by this Hessian bag, and I wondered if you thought elevating it above the sediment that had the bioturbation, if that was part of the success?
Yes, I don't think elevating it above, because they actually quickly get buried. But what it does is it just provides a stable substrate that the seedlings can get established in, get their roots down. After about 9 to 12 months, the Hessian disintegrates, but by then the seedling's well enough to establish that it can actually cope with that sand movement.
Okay, so you don't think that's a...
No, because often...
The bioturbators can still get into the Hessian bag?
Yeah, I guess the bioturbators don't get into the Hessian. You still get, but the bags actually sink into the sediment, so after a month or two you can't see the bags because they're buried. But
So should we have some additional time for questions, because the next talk is actually cancelled?
okay, so I've got an extended question time.
Sorry, nice presentation. Just quick question. Do you have some treatment for the seedling before you mix it with the sand, or directly put it to the sand after you take it from the plant?
Okay, so what we do with the Amphibolis, we don't actually touch the seedlings. They're just naturally released by the parent plants out in the ocean, drift past the sandbag and hook on. So we don't get involved in them at all. With the Posidonia, we collect the fruits off the beach. You have to hold them into the tanks for a week or two so they dehiss and release the seedling. That happens to happen right over the Christmas break when all my staff for some reason want to go off on holidays and refuse to work. So I tend to have to leave them sitting in the tank for 2, 3, 4 weeks or even longer before we can actually get out and plant them. But they seem to be quite happy if you do that, and actually some of the data I've got suggests that holding them for a few weeks is actually better. You get better survival and growth than if you plant them out straight away.
Yeah, so our next talk is going to start at 11:40, so we can continue questions also to the previous speakers. Is there anyone who still wants to ask something to either Jason or the previous speakers?
Marion?
So Jason, I've heard you talk about this work for quite a while now, as you showed on your graph, and it does look like to me that this is a good example of a continuous process that needs to continue by expanding it out to incorporate community groups, etc., to actually have the effect over the size of the area you need. And secondly, it's one of these projects that I think could actually change the prevailing attitude that seagrass restoration isn't successful in these temperate species. It's just the timing. So for you, you're showing a 8 to 10 year window where, which is an appropriate window for restoration of these long, slower growing species. So, have you got any comment about how you can expand it out? So that would reduce the cost per hectare, for instance.
Yeah, in terms of community groups, the issue has come up a number of times, but the problem is, these sandbags are about 20 kilos, and getting them out on a small boat, you might be able to take 5 or 10. So getting the community involved is actually, I think, quite difficult. To do it at any sort of scale, you really need a large barge or something like that that can take out 1,000 bags at a time. You could get community involvement at very small scales in sort of very shallow water potentially. But one of our strategies is to work from the inshore margin of the existing seagrass, which is about 7 to 8 metres deep, and then try and extend shoreward. So I don't think the community really can get easily involved in where we're working. And certainly in time scales, definitely there's a lot of negative perception of this work early on from Department of Environment. Saw the results after 2 years, it's not worth continuing on. They actually pulled all the funding from it and we had to get funding elsewhere. And as I say, it's only because I was persistent and kept going back to these plots that eventually we realised that, yeah, that's the timescale you're looking at, 5 or 10 years to be able to start to demonstrate some success. So we've now got, or looks like we've got, a bit more substantial investment from state government into seagrass rehabilitation. So hopefully we can start to address some of the issues that we've got with the larger scale trials. I've got a few ideas there around, I suspect part of it is bag density. Part of it is there's actually a lot of small scale spatial variation in success. So plots that are even a kilometre apart can have very different success rates. So we need to address that. And I think there's probably fishing disturbance, which is what ripped out all our stakes and stopped us following the longer term, the large scale trials for the longer term.
Thanks, Jason. It's great to see ongoing recovery in the growth rates. That's really exciting because, as you just said, there was a lot of negativity, which was unnecessary. So it's really good to see that changing. With the election commitment, at the moment they've got a sum of money on the table which is roughly 1/50th of what we probably need to do the work. So getting to a scaled up scenario is really important, but also I think, and we've talked before at meetings about optimising the recruitment rates and things and reducing that variance that you just mentioned, and a lot of that's about improving our understanding of the small scale hydrodynamics in and adjacent to those meadows because they do vary quite a lot, which you've commented on before. So what kind of initiatives, bearing in mind some of the stuff Gary talked about those long-term recruitment rates for Posidonia, do you think we could do next to help?
So I think I'd take it from a two-pronged approach. One is that I'm hoping to do get some of the oceanographic modellers involved, and we can start actually mapping dispersal pathways. We've got a reasonable understanding, I think, of where the Amphibolis is. We don't know how the seedlings behave in the water column, so there'll be some empirical work around that. But then the other thing, in terms of, I think, this first step of the government initiative anyway, we don't have the time to do that work. I think we're just going to have to put out a whole heap of small scale plots to start with and see where it works and say, right, it works there, there and there. That's where we'll put some large scale trials.
Just on the seedling behaviour, I think Jennifer had to leave, but she's done some modelling of those seedling behaviours in Perth, around Perth, which could really help inform that because we were hoping to translate her work to Adelaide to help with your work. So there could be some preliminary data that might help you there, yeah.
Yep, yeah, that'd be great.
That was really interesting, Jason. Have you seen the seedlings developing in the new plantings? Do those new plants produce the viviparous seedlings?
We haven't actually looked for them, and I mean that plot now we're only censusing over summer, so we're sort of out there at the wrong time to find them. But I'd expect by now that they should be.
They should be. Yeah.
Just to help you with that, I have found on the beach some of the plants with bits of Hessian attached with seedlings on them. So it's indirect evidence, but maybe they are. They're certainly old enough. Yeah.
Down at Albany, where in the Albany harbours, where there's a really big problem with bioturbation that stops the recovery of seagrass, in places where that's been capped with Hessian or they manage to get the seagrass back, the bioturbators disappear, and then the seagrass can recover.
Yep.
But
So-
that hasn't been documented yet.
Yeah, I mean, if I look into that established patches, yeah, there's a lot less bioturbation within the patch than there is immediately outside of it, so the same thing's happening.
I've got a question for the first two speakers. Both of you observed very large declines in survivorship, both of seed recruits, and Gary knows what I'm going to ask, and seedling survivorship. Why? I know people worry about it, but why worry too much about it? Because it strikes me as a reproductive biologist, I would say that's a normal pattern. These species all start with lots, and only the best or the most lucky survive. So at what point are we trying to overcome what's basically a background level of expected attrition?
I think I can start that one. For our work, we're very intrigued with the concern of 97.8% mortality, because in reality natural populations undergo extreme, that's a pretty good return. If you're less than 0.001% survival rate, you're actually doing very good for a terrestrial plant in many of the in an Australian context. So we've taken the approach that what it is a numbers game. If we are going to plant 20,000 seeds, then we're going to get our densities around about 500 per square metre. And from that, we'll get our one individual per square metre. The other things is that all the best laid plans for increasing your survivalship and reducing the bottleneck can go very wrong season to season. We had large northerly storms that took out a whole significant experiment that were unplanned. You can't plan for what the seasons are going to throw at you. So what we've decided is it's a constant replanting exercise for at least 5 years. If you don't have the minimum amount of effort and energy with seeds, the better. So it's interesting listening to Laura squirt into the sediments. All we're doing with ours is actually just distributing from the boat, much like JJ Orth has done, or Bob Orth has done with Zostra in South Bay in Virginia. I think we worry too much about loss, when to me it's pretty much a natural loss.
I do agree with that, but we are working with a totally different species, so an annual species that's totally dependent every year on having enough seeds for seed germination. And although I do agree that natural seed losses are pretty high, one plant only produces around 100 to 200 seeds. I mean, if you have seed losses surpassing that, then you have a negative population trend. And what we are mostly concerned about is that we're using donor seeds from another natural population. So if we really want to plant on a large scale and we have such really high seed losses, then we would need, we're already using millions of seeds. If we would use billions of seeds, that wouldn't be sustainable. So that's also why we're trying to reduce those losses.
Did we answer your question?
Yeah.
Okay.
Just a quick one.
Good on you, Jim.
Gary, in that 5 years of data, do you have any idea of what, environmental stimulus has caused the flowering to increase or decrease, and looking at it temporally? So if it flowered earlier in some seasons compared to later in some seasons, and if there might have been a temperature effect or a daylight effect or something like that, actually what stimulates flowering to start?
We do have a little, we haven't tested it yet, so it's still sitting out there. We're finding our seasons are getting later, and the actual period of production of seeds is really being heavily focused from about July right through to November, but we're getting a lot more later rains. And we get beautiful, beautiful cold weather in the middle of July. So we actually think it's because there are less rainfall events, not more. There's higher light. It's a higher light to the subtidal beds, and also a lot of these beds are protected because we don't start the northerly storm pattern that usually causes a lot of physical damage to them. But after saying that, it's all conjecture at the moment. We haven't tested it.
Oh, thanks, Jason and Gary. So we'll move